Hello everyone and welcome to our channel. Click the subscribe button and hit the bell icon so you get notifications on the latest uploads. When it comes to the most important part in a car, wait a minute, I know he can talk, but let's talk about real cars. Many people think of engine, brakes or wheels. You know what can happen when your brakes fail? But what about suspension? If you want to explain suspension in one sentence, you would say it controls the ride quality and maneuvering stability of the vehicle. In this video, we'll learn about suspension. So without any delay, let's get started. Let's get into main rules of suspension. Whatever may be the obstacle, its aim is to keep the tires in contact with the ground. It is also used to absorb and dampen road shocks by isolating the chassis from shocks due to bumps. This is also called as suspension isolation. Stability during maneuver is crucial for a good suspension. It is achieved by camber gain, and let's move on to the types of suspension. Now, the first one is rigid link suspension. As shown in the diagram, tires are connected by single rigid link non-independent type suspension. The next one is the strut and link suspension, which is widely used in front-wheel drive cars. The strut is mounted directly on the steering knuckle. The only link down below is the control arm. That's why it is called strut and link suspension. So we have one strut and a lower link. Now let's get into the wishbone suspension. Here comes the best suspension ever developed, and so we start with the word wishbone. It is said that a bird's wishbone is held by two persons and broken apart. The person with longer part of the bone will be granted a wish. The shape was the inspiration for development, and so the name double wishbone. Now let's properly think what we have here. We have the upper wishbone attached to the steering knuckle and the lower wishbone attached down to the steering knuckle, and we have a damper which is connected to the lower wishbone. Now this can be an optional thing. You have two different things as damper attached to lower wishbone and damper then attached to upper wishbone. Let's look at suspension of rear and trailing arm comes first in the list. The arm which connects the chassis with the knuckle is the trailing arm. Have two camber governing links, which are, as the name suggests, they actually govern the camber. Now let's move on to the next one. Multi-link suspension. It is a suspension used in luxury cars. Here multiple links are used so to get a soft suspension and improvise the ride quality. Terms involved with suspension. First thing here is kingpin inclination. It is the angle between the axis joining ball joint centers, also known as the steering axis, with the vertical passing through wheel center. Now here we have another thing, that is scrub radius. It is the distance between the steering axis and the spindle offset when measured from the ground. Now let's get to the next term, which is motion ratio. It is defined as a change in spring length to the change in spindle height from floor. That takes us to the formula MR equals change in spring length divided by change in spindle height. But this value may be unknown in some cases. Well, we have another formula for it. MR equals arm length divided by wheel center length. This is explained by using the strut suspension in the right diagram. Here we have the strut and this is the lower arm. So from the body to the wheel center and then from the body to the arm. So that ratio, motion ratio of arm length divided by wheel length. Now length of lower arm and wheel centers are measured as motion ratio. Next term on the list are CASTOR, camber and toe. CASTOR is the angle between the steering axis and the vertical passing through wheel center when observed in side view. Positive CASTOR is when the steering axis is tilted towards the rear from the front. And camber angle, it is the angle between the wheel axis and vertical passing through wheel center in the front view. Now toe out. Let's understand the toe out. When the front ends of the tires are moved away from each other so that tires diverge, this is called toe out. Toe in is opposite to this, where tires converge. Let's discuss camber in detail. So we have camber and camber gain. When the top end of the wheel axis is tilted towards the car, it's nothing but negative camber. So the top end of the wheel axis is actually tilted towards the car, and then we have the negative camber, which is quite opposite to positive camber. When the car is in motion, there is some change in camber due to bump and droop. This is nothing but the camber change. In this figure, we can observe that the static camber is actually -2 degrees, but when the tire goes in bump or some displacement of the tire occurs, so it increases to -2.8 degrees. So there is 0.8 degrees of camber gain. Now, let's see what is bump steer. It is the unwanted steering movement which occurs due to bump. This can be minimized by proper design and analysis of steering geometry in softwares such as Lotus Suspension Analysis. To learn how to make your custom steering geometry and more about steering, click on the I button and you'll get a playlist of steering geometry. The next thing is torque steer. Due to heavy acceleration, the vehicle gets steered in a particular direction. This can happen due to different torques at different speeds. Let's jump into brake steer. It's an unwanted steering movement which occurs due to improper braking and locking of tires, which makes the car to get steered in a particular direction. To reduce this, we have systems such as A, B, and S, that's anti-brake locking system. This will be the topic for some other video. So until then, don't forget to like this video and share with your friends. Subscribe to our channel and we'll meet in the next video.